In this problem, I'm going to show you a geometric solution to a problem with an airplane that's flying. So we've got an airplane, it's flying at 300 miles per hour, and usually they'll say in still air. So if there were no wind currents, they're planning to go at 300 miles per hour at 60 degrees northeast, okay? However, there's a storm coming in, okay? 50 miles per hour wind, that's pretty strong. The wind's coming in at 70 degrees northwest, okay? So it's gonna kind of blow the plane off its course. Now, we know if the wind blew in exactly the same direction as the plane would be going 350 miles per hour. You just add these two things together. The great thing about vectors is, a lot of times you're gonna have things that are kind of going off in different directions, but adding vectors will still allow you to find the overall speed and direction, or the overall velocity and direction of adding these two things together. So let's get kind of a picture of what's happening here. I'm going to make a sketch here, and you can do this on a coordinate plane. It doesn't necessarily have to be, but anyway, we're starting off. We've got a vector that's pretty long. It's 300 magnitude, okay? And I'm not going to put units with it, but it's miles per hour. And it's at about 60 degrees, okay? So if this is east, 60 degrees north of east would be right here, okay? So anyway, we'll deal with that measure in a minute. The wind is coming 50 miles per hour at 70 degrees northwest, okay? So that would be doing something kind of like this. It'd be a smaller vector. So plane's trying to go this way. The wind is blowing this way. We want to see how does that affect the plane in the end, all right? We want to add these two vectors. Okay, you add these two vectors head to tail. So we've got this thing with a 60-degree angle here. We've got this vector that is a little shorter, but it's heading in this direction. It's got a magnitude of 50, okay? And there's a 70-degree angle. We'll deal with that angle measure in a second, okay? Remember, the resultant vector is going to be the vector that goes from the tail of one to the head of the other, okay? So if your plane's trying to go this way, but the wind is blowing that way, the plane's going to end up going in that direction, okay? And the magnitude we'll be able to get from the diagram and also the direction as well. All right, so what's going on here? So notice I have a triangle that is not necessarily a right triangle. I have a 50-degree angle and a 300-degree angle, okay? I would like to find the magnitude of this vector over here, okay? If you think about it, the law of cosines involves an angle that's being made by two sides, and it allows you to find the third side that's across from that angle, okay? This is the law of cosines problem. I need to find that angle measure. And on the surface, you may be thinking, how am I going to find that angle measure? Well, check this out. If I draw a little horizontal line through here, do you see I've got a pair of alternate interior angles right here? If that's a 60 here, the lower part of this angle here is also going to be a 60, okay? Now, you may be thinking, oh, there's a 60 here, there's a 60 there, it's a 120. Not so fast. This is bending off at a different angle, okay? Put the horizontal in there. Remember, if something is 70 degrees northwest, that means that it's a 70-degree angle north of west. That angle right there would be a 70. So if you draw the horizontal in there, we can see this angle right here is supposed to be a 70. That whole angle is a 130. Okay, and then we're trying to find this third side of this triangle, okay? We can, again, that diagram can be kind of tough to set up, but that's all that's going on here. So we can just pop this into the law of cosines formula and we'll be in good shape. So remember, the law of cosines says that c squared is equal to a squared plus b squared minus 2ab times the cosine of angle c, and we're just going to put everything in. We've got two sides forming an angle that's 130 degrees. So we can make this our A, make this our B. This is angle C. That would make this side C over here. All right, so C squared is equal to the A side squared, 300 squared, plus the B side squared, 50 squared, minus 2 times A times B times the cosine of angle C. The angle C measure is 130, okay? And again, you can just dump all this in your calculator. It works out real nicely. Just got to be careful because there's a lot going on here. 300 squared plus 50 squared minus 2 times 300 times 50 times the cosine of 130. Now be careful, this is c squared. You're going to get a number that's ridiculous. It's about 111,783.6283, okay? Take the square root of both parts. You should get something that seems a little bit longer than both of those two sides if everything worked out okay. So take the square root of that, and we get approximately 334 point, I'm going to round to one place, miles per hour, okay? So the plane's velocity is very big. That's really kind of the dominant term here. What's happening with this vector is it's kind of going north. So in a way, it's kind of adding to the velocity of this plane, but it's also going off in a different direction. And so basically, not all of that velocity is going into the plane's velocity. And so it makes sense that it would be 350 if they were both going in the same direction. Makes sense, a little bit less than 350, because again, those are not happening in the same direction. Later, when you learn about component vectors in either physics or pre-cal, you'll learn a little bit more about how this all works. But that's all that's going on there. Okay? Now, a vector technically has a magnitude and a direction. So if they just ask you for the speed, it's going 334 miles per hour, you're done. If they ask you for the direction, you still have a little bit of work left to do here. Okay? So if you look here, we've got a 60-degree angle here. I need to know how many degrees this angle is right here and add that to 60, and that's going to give me my total direction. I know in my picture it looks like it's about 90 degrees, but you certainly don't want to make that assumption. Okay? Well, we now know that this side is about 334.34. Okay? So we've got a 130-degree angle in here, and we're looking for this angle measure here. I hope you saw the video about the law of sines. Remember, that pairs up sides and opposite angles. And look at what we've got here. We've got an angle, and we've got its opposite side. We've got a side, and we'd like to know its opposite angle. So I'm going to call that angle A, because that's side big A. And we should be able to set up a law of sines equation now. So remember, the side length, so it's about 334.34, over the sine of its angle, is going to be the same ratio as the 50 length over the sine of its opposite angle, which is angle A, okay? And we just need to solve this equation. So it's a proportion we can cross multiply. 50 sine of 130 is going to be equal to 334.34 sine of A. I'll divide both sides by 334.34. And so the sine of angle A is going to be equal to, let's see, 50 sine of 130 divided by that 334, and I'm using the old 334 that was in my calculator. It's going to be about 1.11456 is the sine of A. Okay, so we can take the inverse sine. We need an angle measure here of 0.11456. And again, I'll do the inverse sine here of my answer for my previous thing. And we find out that angle measure there is about a 6.58 degree angle. It's actually a very small angle. And if you think about the triangle, 300 is actually very long, 50 is very short. So that's going to be a very small angle. I didn't really draw it to scale. So what's the overall direction? Well, the overall direction is how many degrees northeast we're flying. So you've got a 60 here, you've got an additional 6.58. So it's going to be about 334.34 miles per hour at about 66.58 degrees northeast. Okay, that's how you could describe your final answer. So some neat math going on there. Maybe some formulas you saw in geometry, maybe you haven't seen these in geometry, but some powerful stuff here happening in this problem.